Okay, so our objective is to graph linear equations. Now this comes out of lesson 13.6. So remember what I said is we're not going to take a quiz, we're just going to take a test on this. This test is scheduled. I'm sorry, I don't know where my red pen went, so I wrote it in green and it's hard to read, but it'll be next Monday, and that will do it for us. I am going to ask you guys tomorrow, we're going to do a book check. Okay, so make sure your books are in the classroom, but I can't do it today. I have to have my paperwork is at home. So we'll do it tomorrow, because you're going to hold your books longer, and I need to let the librarian know so that you can still get a yearbook, even though you haven't technically turned in your textbook. Okay, so first off, what is a linear equation? Anyone like to take a stab in the dark on that one? Oh. Okay, so we're going to graph linear equations, lesson 13.6. What is a linear equation? Page. Very simple, right? Linear has the word line in it, and it tells you what you're going to get when you graph it. So it's an equation whose graph is a line. Okay. All right, so we talked about a couple of different strategies, I think 3 altogether last year when we were graphing linear equations. So we're given an equation and the job was to graph it. What are some ways that you remember that we use to graph a linear equation? Isabel?
You can find the x or y intercepts.
Yep, we can go with x or y-intercepts. That's a great one. So let me ask you this question. What was the equation written like in order for us to find x-intercept and y-intercept?
Was that one y equals mx plus b?
That's a different one. Does anyone remember what it would look like? Hannah, do you remember?
Isn't it you put y is equal to 0?
But what was the equation looking like? You're telling me how to do it. Now, my question is, what does the original equation look like that you go, I'm going to do intercepts on this one? Josiah? No, there is no equation form that's xy equals k, because x times y would not give us a linear equation. Okay? Do you remember, Drake P? Sure, you can give me the name. Not point slope form. That tells you the name of a point and a slope. Page. ax plus by equals c. That's called standard form. When it's written in standard form, it's really easy to let x equals 0, calculate y. To let y equals 0, calculate x. So that's a strategy I use when my equation is in standard form. And that happens to be our first theorem. So theorem 13.6. And it is called standard form. Now, even if an equation is written in standard form, I don't always use it if I end up getting fractions that I have to graph, because I really don't like graphing fractions. So it says the graph of any equation that can be written in the form ax plus by equals c. Now I'm using capital letters. You don't have to use capital letters. We have coefficients a, b, and c show up multiple times in math. And then they give you a stipulation about that a, b, and c, where a and b, oops, are not both 0, and then is a line. So this is the weirdest thing. The graph is a line of this equation that's in this format. Okay, so some things we notice: x is to the first power, y is to the first power. A, b, and c are all numbers. Now, can you remember the stipulation we talked about for standard form in our algebra class about a, b, and c? There's a special rule about them. Do you remember? Well, we just said that here, but that's not it.
Would it be Pythagorean triple?
No, doesn't have to be. Not about Pythagorean triples. There's certain numbers that it cannot be, according to the algebraic definition of standard form equation of a linear function. Mikey?
They have to be real numbers?
Well, that's always the case. You can't graph imaginary numbers. John? Well, you can have negatives. That's not an issue. Knock-Nan, what do you think?
Can it be prime?
Okay, that's just a number, so that's fine. We can have that. Rachel?
They can't be irrational.
No. Here's the deal. They can't be fractions or decimals. Okay, so that would be irrational, but that's not the deal. I've never seen a linear equation with irrational coefficients. So the reality is, in algebra, a, b, and c must be whole numbers, or integers, excuse me. They can be positive or negative, but they can't be fractions or decimals. The other thing is, customarily, the a value should be positive. It's not mandatory, but it is customary that you have your a value is positive, and everything else could be negative if it needed to be. Okay, so that was kind of an extra stipulation. But geometry has a less precise definition. It just says, hey, a and b can't both be 0, because if they are, guess what? You have no x-intercept, you have no y-intercept if they're both 0. So you got to have at least one intercept. Okay? All right, so from here, we're going to take that information, standard form, is easy to determine. Hello, that's a weird word. Determine the x and y intercepts of your graph. Okay, so I'll give you an example. Okay, for the x-intercept, if I had to generically write the x-intercept's coordinates, what would they be? Generically. So don't put numbers in there unless there's a specific number you have to use. Rachel?
X, 0.
Yep, it would be x, comma, 0. When you cross the x-axis, your y-coordinate is 0. So that's what we use to help us figure out the x-intercept. We let y equal 0, which would take out that by term, and all you would be solving is the ax equals c. And if you divided both sides by a, you would get x equals the c over a value. Now, you don't have to memorize all of that. All you have to remember is to figure out the x-intercept, you let the y-coordinate be 0. Bam! And you're done. Okay? And then on the flip side, for the y-intercept, if I wrote down its coordinates generically, what would its coordinates be? Dakota? 0, comma y. So again, this time we're going to let the x value equal 0. So that's going to eliminate that ax term, leaving me with by equals c, and we divide both sides by b. So we would have y equals c over b. Whatever that value is would be our y-intercept. Okay, so that's pretty straightforward, pretty simple what we do there. And then, let's see, what's another way that we graphed equations? I think somebody mentioned it already. What's another way? Probably the most famous way. Knock-Nan.
Y equals mx plus b.
Yeah, what's that called, by the way? Okay, that's slope-intercept form. So let's go to a new screen here. So slope-intercept form is a theorem, 13.7. And the way that that equation is written, it reveals the slope and the y-intercept. So I graph my y-intercept and then I move the slope coordinates to find another point. The issue is I'm always going to get a line. The problem is I don't know if it's right until it gets graded. So that's kind of a problem with it. So a line with the equation y equals mx plus b has slope m and y-intercept b. So again, we're going to take 0b, we're going to graph that first, and then we're going to move the slope value, which we're going to be thinking of as rise over run. We're going to write it as a fraction, and then we'll be able to graph. Now, there's a third way that doesn't have a special name, how we would graph, that we used last year, and it's probably not in your book, because most people rely on these two methods. How else could I graph a line?
Like slope form?
No, well you could, but that wasn't the most typical that people would use. Usually point slope form is what we're going to be using tomorrow when we're writing equations. It's a starting way of writing an equation, and from there we can go to every other form that we want. You guys don't remember creating a table? Picking your x's, plugging them in, coming up with y's, 3 ordered pairs, graph them, and you got a line. If the 3 ordered pairs don't make a line, you've made a boo-boo. Okay? So the most accurate way to graph is through a table with 3 points. Because these 2 other methods only provide you 2 points. You'll always get a line through 2 points. Through any 2 points, there's exactly 1 line. The only problem is you don't know if it's the right line until it's too late. Okay? Because if you've done a calculation error, you're still going to get 2 good points. You're still going to be able to draw a line through them. It just may not be the actual line for that equation. Okay, so let's do a couple of brief examples. And let's see. First one, graph the line 2x minus 3y equals 12. So the way that it's written, what would you suggest that we use to figure out how to graph it, John? Yeah, it's in standard form, so let's go ahead and do it. So for our x-intercept, we let y equal 0, so we have 2x minus 0 equals 12. So we're left with the ax equals c terms. Divide both sides by 2, and we get x equals 6. So we would be graphing 6, 0. For the y-intercept, we have x is 0. Oh, this is supposed to be a plus, sorry. And then we get 2y equals, 3y. Hello. Brain function. We were good with a negative. So this is minus 3y equals 12. And we divide both sides by negative 3, and we get y equals negative 4, which we write as 0, negative 4. And then all I do is get out my graph paper. If you notice, I wrote GP for your homework. That means you're going to need graph paper for tonight. And the only thing I'm going to do is plot those 2 points and draw lines. So I would appreciate if you guys would use a ruler so that things are nice and straight. And you can always use a very expensive ruler, aka an index card. That works too. And you guys should have a lot of those. So notice I label x-axis x, y-axis y. I have 4 arrow caps. I write in tick marks. I focus in on the section where I'm going to be graphing. I don't need to make it a 10 by 10 by 10 by 10. I don't need to do that. I kind of cater to the numbers that I have. I label at least every other tick mark. If you label every tick mark, sometimes it gets really messy. So usually we do the even. So let's graph the x-intercept was at 6, 0. Let's graph the y-intercept. That's at 0, -4. And then I draw a line. So when I draw the line, it passes through both those points, and there's arrow caps on it. Okay, so that's my expectation of what I'm going to be seeing on your homework. All right, let's do another one. Everybody good on this one? Josiah has spoken for the masses. Okay, so this one says graph the line y equals -3/4 x plus 6. Okay, so first thing we do is we identify the 2 key pieces. Now, even though it's called slope-intercept point or intercept form, only one of those values represents an actual physical point on the graph. And that is the y-intercept, okay? And I know it's a y-intercept because when x is 0, y equals 6, okay? So my y-intercept is equal to 6, and I'm going to rewrite it as the ordered pair because I'm going to graph that ordered pair. The slope needs to be written as a fraction. This one happens to be. And from that y-intercept, I'm going to rise down 3 and run to the right 4. And that's how I'm going to do my graphing. Now, for some reason, I've seen a lot of kids struggle because they forget what direction to do first, and they do run over rise, and that doesn't work. They don't pay attention to signs. Now, personally, I always put the negative in the rise value. That way I'm always running to the right. So I only have to pay attention to my rising up or rising down, and that would be it. So we're going to go 6, and we're going to rise down and to the right 4. So again, every graph that I make kind of caters to the information that I have. I don't need to put numbers on the other places because I'm not going to be graphing there. So I'm going to graph my y-intercept is at 0, 6, so right there. And then from there I'm going to rise down 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. That takes me to that point right there. And then I graph. So I draw a line through them. And again, you want to be accurate, and that's where a ruler or the index card comes in handy. Now, do you need to show the rise down and the run, right? No, you don't need to track that, but that's just, I wanted you to see where those numbers ended up. So again, this is your rise down of -3, and then your run to the right of 4. Okay? Now, some people want to do the opposite signs, and so they go upwards by 3 and to the left by 4, and they swap where the negative is, and they put a point that's somewhere over here in the second quadrant. But again, whatever they show me there is what I use. All right, and so that's what you're going to be working on for your homework tonight.